Okay, year 11, some questions have come up about this exercise 511, the area of the sector, so I'm going to quickly do them. So, the first one here is question 8. If the area of a circle is 200 centimetres squared and a sector is cut off by 3 pi and 4, find the area of the sector. Well, here we go. Here's question 8. Remember, the area of the... let's just take the area of a circle. So, the area of a circle is pi r squared equals the area. Oh, what's the area? 200. So r squared equals 200 on pi. What do we want to find? We want to find the area of a sector, and that's a half r squared theta. Now, we know what r squared is. We just worked it out. And we know what theta is because they give it to us. What's theta? 3 pi and 4. All right. And by the way, you should know that that is a formula for the area of the circle. If you don't know that, well, then I'm a bit worried. So, area equals a half. Well, r squared is up here, 200 on pi. And the angle is 3 pi on 4. Well, straight away, the pi's are going to cancel. And what have I got left? I've got 3 times 200, 600, 2 times 8, 2 times 4 is 8, 600 divided by 8, 75. 75 centimetres squares. There's question 8. Now, the next one, I'm just looking back to the email, 13. So question 13, let's have a look at it. A chord. Okay, so we need to draw a circle. So let's draw a circle. That'll do me. And we've got a chord. It's formed by an angle of 45 degrees. So 45 degrees. Let's go there. That's 45. And there. But we've got to be careful. We don't really want to use 45. We know 45 is pi on 4. And we also know the chord is 8 millimetres. 8 millimetres. So, find the radius of the circle. Okay, so what I'm going to do is I'm going to redraw this triangle. I'm going to keep it in the same spot, and I know that's 8. But what I'm going to do is I'm going to drop an altitude. And I know that this is pi on 8. And because it's an isosceles triangle, I swear I did this one in a previous video. All right. Because it's an isosceles triangle, it cuts this in half. So that's 4 and that's 4. That's pi on 8. I need to find this because that's the radius. So I'm now just going to use that part of the triangle. And remember, I used an altitude. That's 4. That's pi on 8. And this is r. So I'm going to use sine because I've got opposite and hypotenuse. Sine pi on 8. And by the way, that's pi on 8 because it's a half of pi on 4. Yeah? Pi on 4 times a half is pi on 8. Just so you know where I got the pi on 8 from. So sine pi on 8 equals opposite 4 over r. So r equals 4 on sine pi on 8. Now, I'm not going to work that out. I'm going to leave that. Oh, well, no, I better do it because they want us to work it out. So what do we got? 4 divided by sine. Now, am I in radians? I'll just better check. So shift, setup. Let's make sure I'm in radians because I'm going to be putting pi on 8. So shift pi divided by 8, close it, 10.45. 10.45 ... which is 10.5 to 1 decimal place, and that's millimetres, which is what they wanted. Now, to 1 decimal place. Find the area of the sector cut off by the angle. Well, now I've got the radius. The area of the sector is a half r squared theta. So it's a half. Now, I've got that answer in my calculator now. So I'm going to use that as my answer. So I'm not going to use the 10.5. I'm going to use that answer in my calculator, but I'm going to write 10.45 ... all squared times, and the angle is pi on 4. The angle is pi on 4 to this sector of this circle. Because remember, now we're finding all this area, and we need to use pi on 4. So here we go. So half 10.45 squared. So I'm going to go, so 0.5, that's a half, times my answer squared times pi on 4. Uh, 42.9, which is the correct answer. Millimetres squared. Okay, what was the next question they asked? Let's have a look at the next one. 15 and 17. I hope they don't mean 15, 16 and 17, because I'm not going to do them all. Okay. What do we got here? 15. Same thing. A triangle is formed where O is the centre of the circle, radius 12, and A and B, the endpoints 15. So find the angle subtended. Okay, so if I'm going to find the angle subtended here, I'm just going to draw an altitude, halve this, which is going to be 7.5. That's a right angle. I'm going to find that angle and double it. I'm just wondering whether or not that's the method that they used for 15, because I've got their work. So what do they call it? Yeah. So they've called it C, and they've gone 2r sine theta. I don't know what they've done, but anyway, that's how I'm going to do it. So here I'm going to redraw this triangle. And there's O, and there's 12, and there's 15, and there's A, and there's B. And I'm going to drop an altitude down here. And that's going to be a half theta, so this is 7.5, and I'm going to use, I don't know, let's call that alpha. So therefore, sine alpha equals opposite 7.5 over 12. So I'm going to inverse sine that. Now I'm in radians, so I'm going to get an answer in radians, and I think they don't want it, they want it in degrees, minutes, and seconds. So with my calculator, I have to reset it. So I'm going to shift it back into degrees. I'll clear that. So what have I got? Shift sine 7.5 divided by 12. Okay, and I've got to times it by 2 because that's alpha. So what do I get? 38. Alpha is 38.68 ... and theta equals 2 times alpha, which is 2 times 38.68 ... So I just take my answer and I times by 2, and they want that answer in degrees, minutes, seconds. 77 degrees, 22 minutes. All right, so there's A. Find the area AOB. So the area AOB is a half AB sine theta. Half AB sine theta. So that was A. The area AOB, because it's a triangle, area equals a half. Well, the two sides are 12 and 12. So 12 times 12 sine this angle we've got here, 77 degrees, 22 minutes. So I'm going to, and I can leave it in degrees. So I'm just going to go 0.5 times 12 times 12 times sine my answer, and I get 70.25, so 70.25 dot 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 70.3. What units are we talking? Centimetres here? Yeah. Square centimetres. C. Find the area of the minor segment. Okay, so the minor segment. So remember, when I have a circle, and I've cut off this, hold on, go there. I've cut off this minor segment down here. So the minor segment is this area here. Well, the area is going to equal, the area of that minor segment is going to equal the area of the sector minus the area of that triangle which we just found out. So the area of a sector is a half r squared theta minus, what did we find? 70.3. I'm not going to go back and fix it up. I'm just going to leave it like that. But remember, my theta has to be in radians. Okay, so I'm going to go back and I'm going to get this angle here. So it's going to be 2 times sine, and I'm going to change it to radians because I want it in radians. So I have to find theta in radians. I don't have to, but I'm going to, because I could have just used degrees. So, clear. So it was shift sine, what was it? 7.5 over 12. 7.5 divided by 12. Did I put too many things in? Too many dots. 38 times it by 2, and I've got that. Now, to find that in radians, I could have just done that. I wonder if I could have just timed it in radians straight away. Let's go set up and see if I can do that. Shift, set up. Let's put in rads. So if I go shift, sine, get out of there. 7.5 divided by 12 equals that, times 2. No, that's not correct. So I'm just going to have to convert that. So let's put it back into degrees. 3, and do all that again. So shift, sine, 7.5 divided by 12. Get that, times it by 2. Now remember, pi equals 180. So we've got degrees. So 1 degree is pi on 180. But I've got 77 degrees and 22 minutes. So I've got 77 times 22. 77 degrees, 22 minutes, times pi over 180. And that'll give me it in radians. So that's what I've got. I'm going to times it by pi. I've got too many times in there. And I'm going to divide by 180. And there's my answer, and I get theta in radians, 1.35. So here I go, a half r squared. Now I'm going to have to use rounded numbers here. So my r, they're all going to be rounded, is 10.5. All right. Is that 10.5? What's my r? Sorry, my r is 12. I was looking at the previous question. Times 12 squared times 1.35 minus 70.3. So 0.5 times 12 squared times my answer, because it was in there, minus 70.3. 26.91. Now that's slightly different from the back of the book, but that's because they would have used rounded, whereas I used my answer. I used my answer, which was not rounded, so 26.92. 26.92 centimetres squares. Final bit. What do we got to find? Goodness me. Find the area of the major segment. Righto. So the major segment is the rest of it. So now I've got the minor segment, area of the major segment equals the area of the whole circle minus the area of the minor segment, which I just worked out. Well, the area of the whole circle is pi r squared, so pi times 12 squared minus 26.92. My answer is going to be different from the back of the book because they got 9.6 because they used a rounded value, but I'm just going to have this and you'll understand that hopefully my answer is more correct. So I've got pi times 12 squared minus my answer, 425.47. 425.47 centimetres squares. They got 425.43 rounded answers. I think mine is more correct, even though I did use a rounded version. Oh no, I didn't, to get all that. Okay, the last one, question 17. So I'm going to create some space now. Righto, question 17. All right, so I've got a wedge, and its cross-sectional area is a sector with a radius of 15. And subtending, find the exact volume. Oh, sweet, this is easy. Volume equals area times height. Even though it's a part of a cylinder, it still uses a volume of a prism. Well, the area of that sector is a half r squared theta, and the height is this value here, 6. Well, what's my r? A half times 15 squared times theta, pi on 6, beautiful in radians, times 6. Now, it wants exact volume. So I'm just going to leave that pi in there. What's going to happen to the 6's? They're going to cancel. 15 squared is 200. Oh, come on. Let's get that. 15 squared is 225. Pi, and I've got a 2 on the bottom. I'm just checking. Yep, beautiful. And that's in centimetre squares. All right. There we go. So that is questions 8, 13, 15, 17. All right.